Good afternoon, everyone. 1 o'clock. Hope you had a good weekend. Let me start off with any questions that you might have. Anybody have any issues with the homework problems for product rule, quotient rule? Everybody's good? So I posted the grades for that test or test quiz that you did last class, and let me just remind you, one of the bad things about doing multiple choice is that, when it's wrong, it's wrong. So I don't want anyone in the class to get too freaked out if you get, a bad quiz grade, that it's going to prevent you from getting an A in the class or something like that. I won't let 1 or 2 quizzes completely destroy your grade. I know for some of you, when I put the quiz grade in, it dropped your average by 4 or 5 points. Don't worry about that. The computer is looking at that as that's your final quiz average for the whole semester. So it's counting it very heavy compared to the one test we have. So right now your quizzes are equally equally represented with the exams, if that makes sense. They're about equal weight right now to the computer. So don't be discouraged, all right? That's why we do paper and pencil tests, so I can give you partial credit, stuff like that. So, okay, we are going to move on. We're going into 2.5 today. So I wrote something here. Make it a little bigger for you so you can read it. So now that we, meaning you, are comfortable with the power rule and the product rule and the quotient rule, you feel good about it. You know how to take the derivative of trig functions, derivative, sine, cosine, tangent. The other 3 you can look up on your formula sheet. Now that we're there, we're ready for the chain rule, okay? And the chain rule, I think it's the most important one because it's the one that comes up the most as you move through and do more math. If you're doing any math related to calculus, the chain rule is just absolutely pivotal. Now, you have to know the others also, but this one, along with being the most important, is probably the most elusive, I guess, difficult for students. It's weird. The chain rule is a weird thing. Some students just get it, and other students just continue to hit a wall with it, and they just can't see the chain rule. So I can't figure that out. I've been doing this for a long time, and I can't figure out what the difference is between 2 students, one who gets it and one who doesn't. I think it comes down to your understanding of functional composition and the difference between composing 2 functions together as opposed to multiplying or dividing 2 functions. So let me get into this. I have notes for this. There is a formula for the chain rule, but I really think that the best way to learn the chain rule is by examples. And so I'm not even going to give you the formula first. I'm going to wait for the formula to the end, because I think the formula almost confuses it in your mind. So I'm going to go straight to examples, and then after we're done, we will do the formula. Now, pay attention today to my usage of colors and highlighters, because everything's going to be very intentional when I do this. All right. So let's start off with our first example. Let's look at the function f of x equals sine of x squared. Now listen to just the way I said that. F of x equals sine of x squared. Sine of x squared. I didn't say sine times x squared because that wouldn't make any sense, right? Sine by itself, right? Sine by itself cannot be multiplied by x squared. This has no meaning mathematically. You can only have something plugged into a sine function. In this case, the x squared is being plugged in. So we have composition here. So the key word here is of. When I say sine of x squared, that tells you got composition, a function inside of another function. So the question is, what is the derivative of this? Right? That's the question. Well, first of all, like I just said, it's not a product. Okay, this is not multiplication. So there is no product rule here. It's composition. So the chain rule is actually how you take the derivative when you have composition. So here's what I'm going to do. I'm going to rewrite the function here, f of x. And now I'm going to start using colors. And I realize you don't have colors, you know, but you're learning this, so just pay attention. All right, so here's what I'm going to do. I'm going to, in green, I'm going to write the sine function. And then inside the sine function is the other function, which I'm going to do in black, x squared. All right. So you can actually look at this as you have two functions being composed. You have an outer function, which would be the sine function, and you have an inner function, which would be the x squared. So we could kind of refer to this as being the inner function, and this right here is being the outer function. One way to kind of remember which is the inner and which is the outer is to think about what you would do if I asked you to plug in a value of x right now. Like if I said, hey, everyone, plug in 1, you would square that 1 first, right? So that's the inner function. And then after you square the 1, then you would take the sine of that. So the sine comes second in the process. So the outer function would be the second thing that happens. The inner function is the first thing that happens. We good? Okay, so here it is. Here's the way the chain rule works. What you're going to do when you have composition like this, the derivative is you first take the derivative of the outer function. Okay, you first take the derivative of the outer function. So the derivative of the outer function is cosine. Do y'all agree? Cosine. But when you write it, cosine, you don't put cosine x. What you do is you put cosine of the inner function, and you do not touch the inner function. So it's kind of like an onion with layers. What you've done is you've taken the derivative of the outer layer of the onion, which is cosine, but then you've plugged the inner function back into that derivative, right? And that is the first step of the chain rule. Derivative of the outer function, plug in the inner function into that derivative. Then you multiply. You will multiply this by, now you move inside to the inner layer of the onion, and you take the derivative of the inside. And the derivative of the inside would mean take the derivative of x squared, which we know is just 2x. And that's it. You're done. All right. Now I'm going to rewrite this. I'm going to put the 2x in front and then times cosine of x squared. That doesn't have to happen, but that's normally the way we would write this. We would bring the 2x out in front. Okay. So you take the derivative of the outer layer. Once you have that derivative, you plug the inner function into it, but do not take the derivative of the inner function when you do that. Then multiply times the derivative of the inner function. All right, let's try another one. Questions?
I have a question.
Yes.
So where did you get that 2x from?
I took the derivative of x squared.
Oh, okay.
I had to use the power rule, right? The good old power rule from a couple classes ago. And that just goes here.
Okay, thank you.
Okay, good. All right, let's try something a little bit different. How about this? F of x equals sine squared x. Now I'm going to put this x in parentheses, even though I don't have to. Okay, I want to know what the derivative of this is, right? What's the derivative of this? Okay, so let's do it this way. Let's first make sure everyone is clear with the idea that sine squared x really means you take sine of x and then square it, right? That's really what that notation means. We have to all be clear on that. Yes? So now what I'm going to do is, again, I'm going to rewrite f of x, but I'm going to write it with colors here. I'm going to start with the inner function. I'm going to do that in black. The inner function is sine x. Okay. The outer function, which would be the thing you do after you do sine x, would be that thing squared. So again, think about what would happen if you plugged an x in. The first thing you would do is take sine of that, right? And then after you get sine on your calculator or whatever, then you would square that answer. So the inner function is the sine x, and the outer function is actually that you're squaring something. You could call that the square function. All right, this is where things start to get a little bit weird. Let's try and get this derivative. Okay, we start with the outer function. And the outer function is like something squared, right? Something squared. What is the derivative of something squared? What do we do?
We bring the exponent, the power to the front, and then
Yeah.
we multiply it to the actual value, and then you subtract 1 from the power.
Okay, so we would bring the 2 out front, right? And then whatever's there, we would subtract 1 from this power. 2 minus 1 would be 1. Do y'all agree that's what would happen if I took the derivative of something squared? But what goes in here?
Would it be cosine x?
Okay, so that you have to be careful with chain rule. When you do the outer layer, okay, you take its derivative like we have. What goes in there is the inner function, but do not touch the inner function yet. Okay, so we will stick with the sine x in here. Okay. Then the next step is you multiply, and now you are looking at the inner function. And you take the derivative of the inner function, which would now be the cosine, and it's tacked on to the outside like that. Which, if I rewrite this, would just be 2 sine x cosine x. And I could put parentheses around these x's. I don't need it, but I will. So there's your derivative. What I did here is I used the fact that anything raised to the first power is itself. So I just rewrote sine x to the first power as just sine x. Questions there? We're gonna do another one.
Why were you emphasizing that the parentheses, like
I'm
you
sorry.
really don't? Why were you like saying that you really don't need the parentheses and then you put it like?
You don't have to put a parentheses. If I write sine of x, that's the same as writing sine of x like this. The only difference between these is that this is very clear that the x is inside the sine function, as opposed to this. You may think that's multiplication. It's not, but you should know that it's not, because you can't have sin times x. Like sin times x doesn't make any sense. So it's understood. It's kind of like when we write a square root symbol, there's a 2 out here. It's kind of the same thing. If I don't write a parentheses around here, it's implied that they're there. Let's do another one. All right, f of x equals, how about this one? The square root of tangent x. I want the derivative. So first, let me rewrite it. The inner function, I'm going to write in black. What's the inner function, y'all?
Tangent?
Tangent, right? That's the inner function. So here's my inner function. And the outer function I'll do in green is the square root, right? So this is my outer one. This is my inner one. Again, if I were to say this verbally, I would say that f of x equals the square root of tangent x, right? And it's that of that lets you know you have composition, a function and inside of another function. All right, so let's go for the derivative here. We start with the outer function, which is the square root, right? So let me call on somebody here. Valerie, you there?
Yes,
Okay, Valerie, the outer function is the square root. Valerie, what is the derivative of the square root of something?
so
What's that?
say the square root.
Yeah, if I asked you right now, what's the derivative of the square root of x, what would you tell me?
Is the square root of x.
This is that one I wanted everyone to like burn in. Remember?
It's X.
Not just x,
It's 1/2.
One
So
divided by two.
One
over 2 square root of x. That's the derivative. That's the derivative of the square root of x, right?
Mhm.
But see here, when we do this chain rule, we're going to do that derivative, right? We're going to do 1/2 square root. But see, we're not going to put x in here. What are we going to put in there?
Tangent.
Tangent.
And
The
then
original inner function untouched, right? Untouched. We're not going to touch it. We're just going to put it right there like that. Now we say times, and then we move to the inner function, right? And let's see, Hale, what do you got? What do I multiply this by?
Be sine over cosine.
That's what tangent is, right? That's what tangent is, but we want to multiply by the derivative of this inner function now, right? The derivative of it. So we need the derivative of tangent now, right here. Do you recall what it is?
No.
Okay, so y'all all need to make sure y'all get to that point where you know the derivative of sine, cosine, and tangent. At least those three you need to just be automatic with, okay? So who's gonna help out?
The derivative of tangent is secant squared x.
Secant squared x. There we go. That's the derivative. Now I could do some stuff. I could move the secant squared x up top. I could put on the bottom 2 square roots of tangent x and box it up and be done. Is everybody catching on to this idea that you have an outer function and inner function? So when you take the derivative, you take derivative of the outer one, but inside of it, inside of that derivative, you put the inner function untouched. And then you multiply that by the derivative of that inner function. It's kind of like you're peeling the onion. You do the derivative of the outside layer first, leaving the inside layer alone. And then you multiply times the derivative of the inside layer. Okay, let's keep going. How about this? F of x equals, this one's going to look almost so simple that it might confuse you. Sine of 5x. I want the derivative. So let me ask, Duck, are you there?
Yes, I'm here.
Okay, Duck, do you see composition here? Do you see a function inside of another function?
The inner function would be the 5x, right?
Yeah, the inner function is the 5x. I'm going to do that in black. And then what would the outer function be?
It would be sine.
Sine. Okay, so I'm going to put sine outside of it like that. So we've got our outer function in green. We've got our inner function here. Good. So all I'm doing is using the colors to kind of illustrate again, what's the outer function, what's the inner function. So go ahead, Duck, you were doing fine here. Where do we start, Duck? When we take the derivative, we
Take
start,
the derivative of the outer function,
okay, which is
cosine 5x.
cosine, right? But inside of it, Duck's already got it. We're going to not put x, right? We're going to put 5x because that's the inner function untouched. But we're not done. We need to multiply this times the derivative of the inner function And Ash, what's the derivative of the inner function?
5.
5. Whoa, what happened? There we go. Yeah, 5. Okay, so another way I could write this would be 5 cosine 5x, just like that.
Professor,
Yes.
I have a question.
Yep.
So how would you know on, like, if you're taking the derivative of something, how would you know when to use the chain rule?
When you have composition, when you have a function inside of a function. If you go back and look at everything we've done up to this point, right? If you look at everything we've done, like last class, when we were doing derivatives, like look at this first example I did last class. If you were to read this, right? Like say it verbally, you would say f of x equals x squared, what? Times sine x, right? This is multiplication between two functions. There is no composition here. There's no composition. There's no function inside of another function. Same with this one. This is this big polynomial, right? Times some other polynomial. So you do the derivative of each one separately. Okay. All of the examples we've done have been like that. Theta, tangent theta. This is multiplication. This is subtraction, right? This is a constant in front of a function. So the constant comes for the right. This is power rule, right? Nowhere have we have intentionally steered clear of any composition at this point. We've intentionally done that. Does that help?
Yes, sir.
Okay. That's why I said in the beginning, I said that, you know, students, sometimes they just get it, sometimes they don't. I think that the real kind of hidden mystery behind that is whether or not students can recognize composition versus products and quotients. If you're constantly thinking that a composition is a product, you're never going to get it right. So let's keep moving. Let's keep moving. I don't know how hard I want to turn the screws here, but let's just turn them a little bit. Okay. Let's just make this a little harder. How about this? X squared sine x squared. I want to know what the derivative is. Ooh. Ooh. We have a situation, right? We have a situation here because we actually do have a product, don't we? We have x squared times sine, but that sine has an x squared in it. So that's composition within the sine, right? So this is like a blended problem. It's product rule along with chain rule. So let me show you how we would attack this. The first thing I would do is recognize that I have a product, okay? So like this is my F and this is my G. And then what I'm going to do is just apply the product rule the way we've learned it, right? The product rule says that what I'm going to do is, I'll write it up here just as a reminder. The product rule is F prime times G plus G prime times F. That's our product rule, right? So for us, I need to take the derivative of F, right? Multiply times G, and then the derivative of G and multiply times F. Understand? Okay, let me write that down symbolically. I need to take the derivative of x squared times sine of x squared plus, and then I'm going to have to take, let me do this in another color, in a different color. Then I'm going to have to take the derivative of sine of x squared and then multiply it times f, which is x squared. Right, that's what the product rule says. If I have two things multiplied together, I've got to take derivative of the first one times the second one, plus derivative of the second one times the first one. Now I just go look at the derivatives and see if I can handle them. The first derivative is the derivative of x squared, which I'm going to have no problem with, right? That's just going to be 2x. I'm happy. Just 2x, and then times sine of x squared. Plus, now when I get to the second derivative over here, this one, that's where I start to have a problem, right? Because I need the derivative of that. right? I need the derivative of that thing in red. Well, wait a minute, hold on. Sine of x squared, isn't that the problem we started with? Isn't that the first problem we did? Sine of x squared? We took the derivative of this a little while ago. And what we did is we said, okay, we have an outer function and an inner function. We took the derivative of the outer one and got cosine, left the x squared in there, didn't touch the inner layer, then multiply times the derivative of the inside function, 2x. And that was the derivative of it, right? So that piece, this work right here actually is going to help us. I'm just gonna, let me just plug the answer in right now. Because we already did the work before, I'm just gonna put the answer in. That right there is the derivative of this right here. And then I still have times x squared. Now, had this been the first time I ever saw sine of x squared, if this was the first time I'd ever seen it, then what I probably would have done is come over here on the side. I probably put sine of x squared like this. And then I would have said, okay, I need to take the derivative of this. And then I would have done all that work that I did before. I'd say, okay, the outer function is sine, so the derivative of that's cosine. I put the inner layer in there, but I don't take the derivative of it. And then I take derivative of the inside, and there we go. We've got it. 2x cosine of x squared. We're done. This is the answer. One thing I could do is maybe put this x right here, make that an x cubed. Okay. Are there questions? I promise you that if you put the time in and practice this, it'll be easy at some point. Like you'll just be like, yeah, you know, but you got to put in the time. You got to, if you're unclear on something, you need to ask questions. All right. Practice, practice, practice. You okay? I'm ready to give you another one. On this particular example, what I gave you was a product rule. But while you were doing the product rule, one of the derivatives you had to take required a chain rule, right? So you could say that this was a chain rule that was within a product rule. Or you could say it was a product rule that required a chain rule inside of it somewhere. I'm going to give you something slightly different. How about this? F of x equals sine of x squared cosine x. Take a moment to think about that. Wow. All right. Does somebody want to kind of share with me what they're seeing?
It looks like it's a product rule inside of a chain rule.
It's a product rule inside of a chain rule. Exactly. You have, if you have here an outer function. So let me write this down. We have here an outer function. The outer function in this case would be the sine function. That's my outer layer of my onion. The inner layer of my onion is actually a product of two functions, but you see that there's no composition. X squared times cosine x is not composition, that's a product. But all of that lives inside of the sine function. So this whole thing, I should do it this way. This whole thing is my inner function, and this one here is my outer function. That's very different than the previous problem, right? The previous problem was I have a product, and one of the factors of that product was a composition. Here we have a composition where inside the inner function is a product. And that's important because that dictates what you're going to do first. Like here, because it was a product, we started with the product rule. But here, because it's composition with a product inside, we're going to start with the chain rule. So let's see if we can do this. The derivative of this will be, well, we start with the outer one, right? The derivative of sine of something is just
Cosine.
cosine. So I'm going to say cosine, but I'm not going to say cosine x, right? I'm going to say cosine of what?
X
times
squared
cosine.
cosine.
X squared times cosine x, right? I'm not going to touch it. I'm going to leave the inside alone. But then the chain rule says times, right? Times. And now I have to go inside and take the derivative of the inside, right? I've got to take the derivative of that. Now, up to this point, everything that we've done, when I've had to take the derivative of the inside, it was something we could just look at and do, right? We just, oh, the derivative, that's just 2x. Or, oh, derivative, that's this. It was easy, relatively speaking. The derivative of the inside here requires a product rule. So what I'm going to do is on the side here, I'm going to just take that inside function, x squared times cosine x. And I'm going to run my product rule on this, right? I want the derivative of this product. And so I'm going to do the derivative of the first one times the second plus the derivative of the second one times the first one. And then I have to crank this out, right? Oh, I forgot the prime marker here. I'm sorry. It was the derivative of the first one times the second plus derivative of the second one times the first. So let's see here. Are you there, Red? Give me a second. My wife never calls me. Okay, sorry, she forgot that I was in class. Okay, so Red, no, Red's not here. Okay, how about Alec?
Yes, sir.
Okay, you ready?
Mhm.
Crank out that derivative over here for me. What is it?
I got 2x times cosine x plus negative sine x, x squared.
Good. Okay, so what I did is I just went ahead, since it was a plus and then a negative sign, I just made it a minus sign. Is that okay? You know what? I'll change it. I'll make it plus and then I'll make this negative sine x so everyone can follow here. Like that. And then on the next line, I'll clean it up. This will be 2x cosine x minus x squared sine x. So again, what I've done here is what I've been kind of doing a lot. Anytime we have something like x squared or a number out here, I bring it down in front. The plus negative becomes minus, and that's our derivative. Now that's the derivative of the inside, right? So that gets tacked on to the backside of this. You understand? The whole thing gets tacked on right here. Very important, and students always lose points on tests for this. This, like this, written like this, is incorrect. Because this is multiplication and we're multiplying all of this times the derivative, this must be in parentheses because you have two terms, right? You have two terms, which means that this would have to distribute through here and here if we were to multiply it out. That's what would have to happen. So we have to have that in parentheses, but it's only because we have two terms. If you look back at all the examples we've done, we've never had that happen. When we did chain rule, we've never had two terms out here. Questions? Can you see how things can get very complicated, right? Because you've got like all these rules that kind of interact with one another. Do another one. This one I'm going to call y instead of f of x, okay? What if I wanted you to do x to the fourth plus 5x squared plus x to the negative 1 all to the 8th power times 4x to the 7th minus 8x cubed plus 1 all to the 10th power. And I want the derivative of this. Now I know this looks terrible. All right, it looks absolutely horrific. But we can do this if we just kind of take a deep breath and just analyze what we have here. So let me ask. Devin, you there?
Oh, yes, I'm here.
Okay. Devin, what do you see here?
It's basically a product rule, right?
Yes, it is a product rule.
Multiply.
Everyone see that we got a product right there. So we have these two things being multiplied. Okay, Devin, so in that case, everything over here, we call that F, right?
Yeah.
And then everything over here, I could call that G. Y'all with me? Y'all with Devin on this? So following the product rule, I'm going to have to take the derivative of the first one. So Devin, when we take the derivative of this first one, what are we going to have to do here? Because it's all of this to the 8th power, isn't it?
Oh, yeah. Mm-hmm.
It's all of this to the 8th power. That is composition. That's everything to the 8th power. That's this thing. It's the x to the 4th plus 5x squared plus x to negative 1. All of that's the inner function. The outer function is the 8th power.
Oh, okay. Yeah.
Does that make sense, Devin?
Yeah.
And then, so we're going to have to take the derivative of this, which is going to be a chain rule, times this, plus the derivative of this, which is another chain rule, times this. Okay, this is getting insane. All right, let me write this down. The derivative of this should be, okay, we have to take the derivative of the first one. We have to take the derivative of the first one. Oops. So here's the first function, f, right? This is f. We need to take its derivative. Then we will multiply that times g. Without doing anything to it. Plus, then we have to take the derivative of the g function. And then multiply it times the f function without taking the derivative of that. So maybe I should do it this way. This right here means I've got to take the derivative of the first function. There's a derivative of the second function, right? So if you just squint your eyes, take a step back and look, this is like f prime times g plus g prime times f, right? So overriding everything here is a product rule. Do y'all see that? Are there any questions on that? Does everyone see the product rule? Okay. Let's see if we can't, if we're ready for this. I'm ready to do the derivative here. Let's see if we can't do this one without writing any scratch work down on the side. And to do it, I'm gonna walk through it with someone. So let's see, Alec, we already called on Alec. Enrique, you there?
Yes.
Okay. Where are you? Where's Enrique? I don't see you.
Oh, my
Okay, there, I see you on the screen now. Okay, Enrique, I want you to focus all of your attention on trying to find the derivative of f, okay, which means trying to find the derivative of this.
Okay.
Okay, so what's the inner function?
Would it be the everything inside the green parentheses?
Everything inside the parentheses. So x to the 4th plus 5x squared plus x to the negative 1. Okay, what's the outer function?
So it'd be the 8th power rule?
The 8th power. I'm glad you said power. The 8th power. So when we take the derivative, Enrique, you have to start with the outside first, right? That 8th power.
Yeah.
And what is the derivative of something raised to the 8th power?
So you take it out and then subtract 1.
And then subtract 1, right? So it'd be, the question is, what's going to be raised to the 7th?
The inside.
The inside, untouched, right? Untouched. Yeah. Okay, good. So we're going to do this. Now that's the first step of the chain rule, right, Enrique? We have another step because we only dealt with the outer layer.
Yeah.
Enrique, what do I put next?
Then you multiply it by the derivative of the inside.
Perfect. So we're going to multiply by the derivative of the inside now. And Enrique, can you give me the derivative of the inside? There's pluses between these, right? So you can just do them one by one, can't you?
Yeah.
Okay, so what about x to the fourth?
So would that be 3x to this? No, 4x to the third power.
4x to the third, good. Okay, then what about this next one?
So would that be 10x?
Plus 10x, good. And just don't freak out here. Just do the rule. Bring the -1 out, right?
Negative 1x or negative x to the -2.
Perfect. Okay, that's it. You're done, right? That's the derivative of the inside. Now you have to put in parentheses again, because you have more than one term here, and this all multiplies times it. So Enrique, that was perfect. Does everyone follow what Enrique did there? Any questions? We're not even close to being done, all right? But we've got the first derivative of this done, right? This first derivative here, we've got. The next thing is I need to multiply times g. So I'm not going to do anything. I'm just going to write g down here. I'm going to run out of room, I think. Then I do plus, and now I'm ready to move on to the derivative of g, which is the derivative of this stuff in blue. And David, you there? David Sandoval?
Yes.
Okay. So Enrique just like hit that out of the park. So did you follow that?
Yes.
Okay, good. Do you see composition here? Do you see an inner and outer function?
Mhm.
Okay, so go ahead. If you feel good with it, you can just tell me.
So it's gonna be 10,
Okay,
and then in parentheses you put 4x, 7, you put a minus 8x cubed plus 1,
okay.
and then you're gonna take the derivative of that
Okay,
one.
what power do you want me to put on this? Do you want me to put a power?
Oh yeah, 9.
9. Okay, good.
yeah.
So that's the power rule, right?
Mhm.
That's what just happened, everyone. David just did the power rule, took care of the outer layer, the 10. And now what do you want me to do? Times what?
Times the derivative, so parentheses,
Okay,
and then it's gonna be 7 times 4,
28.
28 x to the 6, and then negative
24.
24, then x to the second, and then 0.
And then derivative of 1 is 0, so I can be
Yeah.
done there, right?
Yeah.
Okay, good. We're done with the derivative of g. The only thing left to put out here is f, untouched, just leaving the f alone. That's the finish. That's us finishing the product rule. Okay, let's take a poll. Let's see how you feel about this. Are you feeling pretty good? Yes. Are you feeling like, oh shit, you know? Yay or nay? So I'm sharing my results. I've got 81% of the class says they feel pretty good about this. Now, look, I will admit to you, that derivative is horrific looking, right? I mean, that is just a mess, but it is the derivative, okay? That is the derivative. So this chain rule is extremely powerful because it allows us to take derivatives of pretty much everything. Look, there's nothing really left for us in terms of derivatives that we can't handle, with the exception of exponential, log, and inverse trig functions and hyperbolic functions, which we haven't even talked about yet. But the main idea here is that we can handle composition now. All right, we can handle it. All right, I'm going to keep moving. I'm going to look. The chain rule is the chain rule. That's it. I mean, inner, outer, you've got it. I mean, there's nothing more to it. All right, but it can get a little weird. So look at this one.
The last one will be okay with the last result, right? You don't have to actually solve it, like multiply the 8 or
No,
Like-
no.
no, right? Okay.
Now, we could do some factoring here. It's kind of disgusting, but you could do some factoring. Like if you look at this as being like two big terms. You could say that the X, this right here, there's 7 of them. And over here, there's 8 of them. So you could factor out 7 of those. And then on the, this one right here, there's 10 of those. And then here, there's 9 of those. So you could factor out 9 of those. So there is more algebra that could be done here, but for us, raw derivative for now, this is fine, okay? This is more, I'm more than happy with that. Okay, we're gonna go again. Ready? Changing it up a little bit, slight little difference. Remember the first problem. I forgot to silence it, I'm sorry. Remember the first problem. I'm just gonna put it up here in the top right corner. The first problem we did today was sine of x squared, right? And when we did that, we found that the derivative of that was cosine of x squared, and then we had to multiply by the 2x to get the chain rule, right? Okay, here's the new one. Here's the new problem. What about, what about f of x equals no, let's do it this way. Sine of x squared. Whoa. Sine of x squared. Sine of x squared. We have not done one like this. This is a triple composition. You don't just have an inner and an outer. You have an inner, a middle, and an outer. An inner, a middle, and an outer. You with me? The inner function is this one. The middle function is that one. And the outer function is that one. Again, think of it as if I asked you to plug in x, the first thing you would do is plug in right here and get whatever x squared is. That would be the first thing you do. Then you would take sine of that answer. Okay, whatever you get there, you get, and then you would take sine of that answer again. Right? So let me write it this way. We have f of x equals, I'm going to do this in colors. We have the outer function is sine, right? Like this. And then inside of that, we have cosine, right? And inside of that, we've got x squared. Do y'all see that there's no products here? There's no multiplications. It's not, sorry, I don't know why I put cosine. I apologize. Sorry, it was sine. The outer function is sine. The middle function is sine. The inner function is x squared. So how do you think this is going to work? If what we were doing before was that we started with the outer function, we took its derivative and then plugged the inner function into it, right? And then multiply times the derivative of the inner. How do you think this is going to work? Any guesses?
I'm thinking
The same
that-
way.
Okay, but how? With 3 of them, how do you think it would work?
You can first solve the outer, and then when you have already that,
Okay, let's try it.
move on
Let's
to
see.
the inner one.
Let's see if y'all are on track here. So the first thing you're saying I should do is take the derivative of the outer one,
Yes.
which is the green sign, right? The green one. And the derivative of sine is cosine. Okay, so I do cosine, but what goes in it?
Sine of x squared.
Everything in here untouched, okay? The remaining 2 layers inside untouched. So I'm going to put the sine and then the x squared inside of that. And now what I've done is I've taken the derivative of the outer layer, plugging the inner layers, both of them in untouched. Then I will multiply. Now what? By what?
You
You
can
can
decide.
touch the in one and to the middle.
Yeah, we've done this one, right? It's kind of like we've done the outer layer. So now you're looking at this layer, right? And you're trying to take the derivative of this one, which is
Cosine x squared.
cosine, okay, but cosine of what?
X squared.
X squared.
X squared, okay? You're not gonna touch the layer inside of that. And now you've done the sine. And now you move in and you multiply a third multiplication or a third factor here. Now it's the derivative of the inner layer, which is 2x. So the derivative of sine of x squared is cosine of x squared times cosine of x squared times 2x. That was an onion with 3 layers. There is no limit to how many layers your onion can have. It's the same principle. You could have 5 layers, you could have 10 layers. You're going to do the same thing. Let's see if you really grasp that, okay? I'm going to give you a big onion here, okay? This is similar to a problem in the book. Y equals sine of 5x. Okay, so I got to get the number of parentheses right here. This 5x is in this sign, so that parentheses goes here. I have 1, 2, 3, 4, 1, 2. I need 4 of them this way. This onion has 1, 2, 3, 4, 5 layers. You plug in x here. That's the first layer. The next layer out is sine. That's your second layer. The next layer out is sine again. That's your third layer. Next layer out, sine again. That's fourth, and then finally the fifth, sine. So let's see if we can do this derivative without colors. Okay. I start by looking at the outermost layer, which is this one, and I take its derivative. What's derivative of sine of something? Well, cosine, right? But what goes in it?
Would it be the whole thing?
What do you mean? What whole thing?
Well, the from the second sine to the 5x.
Yeah, so it'd be sine of 5x, right? That's what's going to go inside of this cosine. The sine of 5x. That's what lives in this inside of that cosine. Times. Now where am I headed? The second layer, right? The derivative of sine again. What's the derivative of sine? Cosine.
Cosine.
Cosine, but cosine of what? How many sines?
Third
2.
sine forward to 5.
2 of them, right? The sine of 5x. Shit. Okay, so now I've done 2 of the layers, right? I need to keep going. Now I'm going to move to this one. What's the derivative of sine of something? Well, we've already done this now, right? So cosine, but what goes inside of that? How many sines?
1 and
Just
5.
1.
1. So it's just the sine of 5x. I'm out of room, but I'm going to just continue on the next line. Then I say times. Okay, now I need to go to this one. What's the derivative of sine of something? Cosine, right?
5x.
Cosine of 5x. Am I done?
Just 5.
One more thing. Yeah, one more thing. Good. You got to take derivative of that one now, which is times 5. So the derivative of sine of 5x is cosine of 5x times cosine of 5x times cosine of 5x times cosine of 5x times 5. I'm the messenger. Okay, this is what chain rule is. Okay. Let's do something different. Let's see, time wise, we're good. Let's see here. All right, how about this? Y equals x over x squared plus 1 all to the fourth power. Take a moment to look at that one. And then after you look at that, I want you to see, I want to see if you can figure these out on your own. Or maybe I'll put you all in breakout rooms. I don't know. Do y'all want breakout rooms or? Let's see that one. And then how about, ooh, this one. Sine of the square root of x squared plus 1. Okay. I'm going to do breakout rooms. 2 problems. See if you, I mean, if you don't want to talk to your breakout room, that's okay, but I'm going to at least do it if y'all want to check each other. 10 minutes, 9 minutes. Okay. Let's see how you do on this. The breakout rooms are only going to have 2 to 3 people in it. That way there's not like too many people there. There you go. I close the breakout rooms and it gives everyone a minute to get back here. So we'll just hang on for 30 seconds. The answers, the cleaned up, simplified answers are shown. Okay, we're all back. All right, so I'm going to relaunch the poll. I'm just asking about the first one. Yes or no, did your group get the answer to the first one? That now I'm only showing the very cleaned up version of it. Let me go ahead and show you all the work. That way you can really know if you got it or not. So if y'all got this, that would be okay. It's looking about 60, 70, 65, 70% of y'all got the first one. Okay, let's just talk about the first one then. So on the first one, we see, well, hopefully you see you've got composition, right? You've got an inner function raised to the fourth power, right? Inner function is this, everything in here, which is a quotient, by the way, and it's being raised to a power. So we start with the power, we bring the power down 4, and then we rewrite the inner function to the third. Then we multiply by the derivative of the inside, which is a quotient, so it requires the quotient rule. So you do derivative of the top, which is 1, times the bottom, minus the derivative of the bottom, which is just 2x, times the top, all over the bottom squared. Now is a perfect time to ask a question. So 30% of y'all didn't get it. Do you see now what you got wrong or what y'all did wrong or how you approached it wrong? There are no questions? Now I did clean it up. I did multiply the 1 through, which really just leaves you with x squared plus 1. And then these two together give you negative 2x squared. And so I put x squared, take away 2x squared, that's basically negative x squared. And I wrote this as 1 minus x squared. And then the bottom was x squared plus 1 squared. Over here, what I did is I just cubed the top and cubed the bottom and got rid of these. And then I just put everything together. I put the 4 with the x cubed with the 1 minus x squared on top. And then I put the x squared plus 1 cubed times x squared plus 1 to the, oh shit. I forgot to put 5 there. I'm so sorry. 5. My fault. I apologize. That's a 5 down there. Because it's this cubed and then this thing squared. So when you put them together, you add the exponents and you get a 5. Any questions on the first one?
Would we need to write like on the test what's in the red box, or would we have to clean it up and write what's in the blue box?
On your next test, which is on the 10th of March, I would just want what's in the red box.
Okay.
Okay, how about the second one? Let's relaunch this poll.
The 5 is just by, okay, I'm sorry. The 5 is just by adding 3 and 2, right? It's just addition of the exponents, right? Nothing else.
Yes, yeah, that's all I did
Okay.
was just added exponents. Okay, so I'm asking on the second question, did you and your group get the second one right? So it's about 60-40 here, 60-40, 65-40. So this is a triple composition. You have an outer function of sine, middle function of square root, inner function of x squared plus 1. Excuse me. So you have to start on the outside. Derivative of sine of something is cosine of it. So you just do cosine and you leave all this untouched. times, and then you take the square root, right? You take the derivative of that. The derivative of the square root of anything is 1/2 square root of the inside function untouched. Then times the derivative of the inside function, which is just 2x. These twos cancel. I put the x in front of here. And then I just made a fraction out of it. And these do not cancel. Okay, those don't cancel because this square root's trapped in the cosine. So that doesn't happen. So you just have to leave it like that. How are y'all feeling? You're gonna need to practice, right? You're gonna need to practice. My recommendation is to do as many problems between number 1 and number 42 on the homework as you possibly can. Our homework assignment for this chain rule has 1, 5, 6, and goes up to like 38. I would say try and do as much as you can between 1 and 38. Even like 1 and 44, just, you know, do as many as you possibly can. Because each one of them has just a kind of a different sort of thing happening. And so you can't just do like 5 of these and be like, yep, I've got chain rule down. You got to see how each sort of function can throw its own unique little twist into it. All right. I don't have enough time to show you 100 examples, obviously. I can only show you so much, and I can only get you to kind of understand like the basic idea of the chain rule, right? And now it's going to be married with the product rule and quotient rule and power rule. It's all married together now. Okay, I have another one for us to look at. If f of x equals 2 cosine x plus cosine squared x, find all the points where f has a horizontal tangent line. There was a problem kind of like this in your homework from last time, or maybe it was the time before. What I'm going to do here is I'm going to show you the graph of this function first, okay? Just to kind of get us motivated here. Y equals 2 cosine x plus cosine x squared. So this is the function that we're talking about. Let me double check. Yeah, it's 2 cosine x plus the cosine function squared. Here's the graph of this. Okay, that's what it looks like. And what we're being asked is to find all of the points where the tangent line is horizontal. Meaning, figure out where that right there at the top peak, that tangent line is horizontal, right? Down here, horizontal. Up here, horizontal. Down here, horizontal. Down here, horizontal. Up here, horizontal. There are an infinite number of answers here, right? There are an infinite number of points where the tangent line is horizontal. Do you all agree? There's an infinite number of answers. So let's see how we're going to do this. All right. What we're going to do is we're going to think about what this means, right? To say that your horizontal, that your function has a horizontal tangent line means that the derivative of the function, right, which gives you the slope of the tangent line, must be 0. Because horizontal lines have a slope of 0. Y'all agree? Horizontal lines have a slope of 0. So saying where is a tangent line horizontal really means where is the derivative 0. So that means I need to take the derivative and set it equal to 0, which I told you a while back, like we're going to eventually have to set our derivatives equal to 0. This is an example of us doing that. So I'm going to start with the derivative. I need the derivative before I can do anything else. So fortunately for us, there's a plus sign, right? And because there's a plus sign, I can treat these two functions in like separately and take the derivatives of each one individually. On the first one, this is a nice one because it's a constant in front of a function. The constant will come for the ride, and I know the derivative of cosine, right? So this is just going to become 2 times negative sine x. I'll fix that in a minute. I'll put the negative in front of the 2. but that's just me taking derivative of that piece. The cosine squared, on the other hand, I need to look at that as being cosine x squared. And then when I look to take the derivative, I have to see the chain rule. I have to see the inner function is cosine, the outer function is the squared. So let's see. Jose, did I call you already? I feel like I called you.
No, sir.
No? Can you give me the derivative of the cosine x squared?
So that'll be 2 times cosine of x in the parentheses,
Okay,
and then times the derivative of the inside, which is negative sine x.
there you go. Now, technically, there's a 1 up here, right? Because you brought the power down, you subtracted 1. But
Correct.
because you know it's a 1, I think you just didn't even write it, which is fine. I just want to make sure everyone understands the power rule is in play there. We have to subtract 1 from the 2. Okay, now there's a plus sign here, right? I didn't write it here, but that plus sign comes down. Right, that's our derivative. Any questions? I want to clean it up. This is going to be -2 sine x. And then this negative, I'm going to pop it out here and make this a -2 cosine x times sine x. And that is my derivative. And I'd like to know when it's 0, right? That's what I want to know. This right here means I want to take that and set it equal to 0, right? Set that thing equal to 0. So I'll do that here. All right, now you are back in pre-cal. This is a pre-cal problem. This is out of a topic called solving trig equations. So I need to solve this equation for x. So the way I'm going to do this, by looking at it and kind of analyzing, I'm going to factor first. I'm going to realize I can pull a -2 sine x. Both of these have a -2 and a sine x in them. So I'm going to factor it out. And when I factor it out, I will be left, well, when I pull the -2 sine x out of there, there's nothing left except a 1. And then over here, when I pull this -2 and that sine x out, the only thing I'm left with is cosine x. And the way we solve these things is once you get it factored and you have two things being multiplied, I just set each factor to 0. So I set -2 sine x to 0. And then I set 1 minus cosine x equal to 0. And then I have to solve each of these.
Professor, I have a question.
Yes.
Would the inside the parentheses be a plus cosine x? Because you.
Oh, yes, thank you. Sorry, thank you. I pulled the minus out. I apologize. Thank you for catching that, Jose. On this first one, divide both sides by -2. You get sine x is 0. Over here, subtract 1 from both sides, you get cosine x is -1. And now here's where you go back and you think about the unit circle. And we've had this come up in this class a couple of times now, where we're going back to the unit circle and we're saying, okay, remember that on the unit circle, if you take any point on the unit circle, the x coordinate is cosine of the angle and the y coordinate is sine of the angle. And so when we're asking when is the sine function 0, we're saying where on the unit circle is the y coordinate 0. So this is the way I actually like to do it. I like to underneath here draw a little unit circle. And then I like to say, okay, the two places where the y coordinate are 0 here and here. These 2 points. And so that means that this x, the angle, right, that x must be, what are these angles? What are the angles corresponding to these points?
0 and pi.
0 and pi, right? But we could be at 0, we could be at pi, we could come around to 2 pi, we could go around again, we could be at 3 pi, or we could be at 4 pi, or we could be at 5 pi, or 6 pi, or 7 pi, or 8 pi, or 9 pi, or 10 pi, or 11 pi, or 12, right? So again, back in pre-cal, you learn how to write these two answers in a general form using either an n or a k. I'm going to use n. So I'm going to say here, the answer here is pi n, any multiple of pi. At any multiple of pi, I'm going to get a solution. Now on the other one, again, I draw my unit circle and I'm asking cosine of x is -1. Well, cosine is the x coordinate, and the only place that the x coordinate is -1 on the unit circle is here at pi. But that's already, we've already covered it with these answers, haven't we? Like these answers include that answer. So we're done, pi n. At every multiple of pi, we have a horizontal tangent line. Do you believe it? Let's go see. Let's go back to the graph. I'm going to change the graph so that the x-axis is in terms of pi. Yeah, like this. So notice that my x-axis has pi's on it now. And notice that if I go to every multiple of pi, so 0 is a multiple of pi. I go here, I've got a horizontal tangent line. If I go to pi, I've got a horizontal. If I go to 2 pi, I've got a horizontal. If I go to 3 pi, I've got a horizontal. 4 pi, I've got a horizontal, right? At every multiple of pi, even the negative multiples. Try and get 2 more examples in. So the next one is, let's say that we have y equals secant of x squared. Find y double prime. Okay, I already know this is going to be a mess. Let me get myself ready for this. All right. I want the second derivative of this, which means you have to take the derivative, and then after you finish that derivative, you got to take the derivative again. So when we go to do the first derivative, does everyone see chain rule? Inner function, outer function? Yes. So let's start this out. The first derivative. Okay, we start with the outer function. The outer one is secant. What is the derivative of secant? Careful. What is the derivative of secant? Let me write it down over here. If we take the derivative of secant x, this was one of the ones where I told you don't necessarily need to memorize it.
Secant x tangent x.
It's secant x tangent x. That's the derivative of secant x. But here we're taking the derivative of secant x squared. So when we do the derivative of the secant, when we do that part, right, when we take the derivative of this outer function, we're going to get secant something tangent something. But what's the something?
The x squared?
The x squared. That's right. Oops, I almost messed that up. It's secant x squared tangent x squared. See, we're doing the derivative of the outer one, which is secant. But inside that derivative goes the inner function untouched. Then what? Am I done or what?
2x.
Times 2x. Oh gosh. Oh gosh. We're supposed to take derivative again. Oh man. Okay, let's just do the first derivative. I think this one's too much. How about this? I'll offer that as a bonus. Take the second derivative. So take the derivative of that again. That is a bonus problem. And we'll do it like we did on the last one. If you remember, you'll turn this in with your exam. The next exam we take, just put it as your last page. The second derivative of this. I don't want to do it. It's a triple product. And then within that triple product, you have chain rules. So it's a little uglier than I wanted it to be. My main thing was to get you to see, I wanted you to make sure you understood how you take the derivative of secant of something that's, you know, something different than just secant x. It becomes secant of the x squared, tangent of the x squared, and then times the derivative of the inside. All right, last one. Well, maybe the last one. We'll see. How about this one? Y equals sine of 3x. Find. What does that mean?
The 50th derivative.
The 50th derivative of sine of 3x. All right, so let's just start taking some derivatives to see what happens. The first derivative of this is chain rule, isn't it? This is chain rule. So I start with the outer function. Derivative of the outer function is cosine, but I plug in the inner function untouched. Then I multiply times the derivative of the inside function, which is 3. Right? Because you have to take derivative of that 3x inside. And I'm just going to rewrite this as 3 cosine of 3x. Just put the 3 out front. That makes sense? Let's look at our second derivative. So when we take derivative of 3 cosine of 3x, this 3 will come for the ride, won't it? So it's just going to come for the ride times. Now I have a chain rule that I have to do on this cosine of 3x. The outer function is cosine, the inner function is 3x. So I start with the outer function. And let's see here. Sophia, are you there?
Yes,
You understanding? Kind of?
I think so.
Okay. I'm giving you the task of giving us the derivative of cosine 3x. So start with the outer function, right?
The derivative of cosine is negative sine, right?
Yep, negative sine. And then what goes
And then
in
you
that?
take the 3x
3x. Okay.
and then multiply by 3.
Times 3.
And then
Is that
it'd
what you
be
said?
like-
Times 3?
Yes.
Okay, that's
Would
it.
it be negative 3 sine 3x?
Yeah, well, this 3 will come out here and join up with the negative and the 3 out here. It will join. Okay. So we could write it this way. We could write it negative 9 sine 3x. Right? That's the way we could write it. Let's go again. Third derivative. We have to get to the 50th derivative, but something tells me we're not going to do 50 derivatives. We're going to find a pattern. Okay, so let's see here. Landon, you there?
Yes, sir, I'm here.
Okay. All right. What do I do with that negative 9?
Negative 9.
Mhm.
Negative 9. I'm not entirely sure, sir.
Well, it's a constant in front of the function, right?
Yes.
What happens to constants in front of functions when you take derivatives?
We take derivatives, they are simplified. What am I saying that right?
How would I simplify negative 9? I'm not sure what you mean. If you have a constant in front of a function and you take the derivative, the constant, who's helping?
Just leave it aside and then multiply at the end.
Right, comes for the ride. That's all. It's just going to be tacked on out front. Okay, that negative 9 is irrelevant to us. We just need to bring it with us because it's a constant in front of a function. And then we take the derivative of what's here. Okay. Now, the derivative of the sine of 3x, Landon, you want to go for that? Outer, inner?
No, sir, I'm a bit confused right now. I'm sorry.
Okay, okay, it's all right. Well, thing is, make sure that you get assistance on this, right? You're not, if you're really lost on this chain rule, if anyone is, this is it. This is like make or break day. If you can't do chain rule, the rest of the class isn't happening for you. All right, chain rule must be understood. All right, so you need to seek help if you need it, because it's not something where you can scrap it, you know, just kind of scratch and claw. No, it's the end of the road if you can't get chain rule down. So please reach out for help. All right.
Yes, sir.
I don't mean to, and I don't mean that in a mean way. I'm being just honest with everyone. Okay, Matthew, you there? I don't see Matthew. Roberto.
Yes.
All right. Derivative of sine 3x.
My -9 cosine 3x times 3.
Times 3. There you go. Okay. So it was a derivative of sine, which is cosine. You plug in the 3x, you don't touch it. Then you hit that with the derivative of the 3x, which is 3. Do y'all see that as we take derivatives, we keep on adding in 3, like a factor of 3 each time? Like now I'm going to hit the -9 with 3. So it's going to become -27. And then next time I do it, it's going to become bigger and bigger, just each time going up by 3. Do y'all see that?
Yes.
I'm going to stop doing that because these numbers are going to get too big. So instead, what I'm going to do is I'm going to rewrite that as -3 cubed cosine 3x. What I'm doing is I'm understanding that each time I do this, I'm getting another factor of 3 to pop out every single time. And so the first time I did it, I had 2 3s here. So this was really a 3 squared. This one was really a 3 to the first power. So I had 3 squared. I mean, sorry, 3 squared, 3 cubed. The next one should probably be a 3 to the 4th, right? But let's just work it out. Let's just keep going. On the 4th derivative, how am I doing on time? 5 minutes. On the 4th derivative, let's see, the -3 cubed comes for the ride. The derivative of cosine is negative sine of the inside function with no derivative, right? So that's the derivative of the outer one with that one, then times the 3. There's that next 3 that's going to pop out, right? So now check this out. These two negatives come together and become a plus. So now I'm at 3 to the 4th sine x. Sorry, sine 3x. Questions? We're starting to develop a pattern here. Do y'all remember that I told you that when you look at original function, that's the same as the 0th derivative? When you don't take the derivative function, it's called the 0th derivative. The 0th derivative was positive, wasn't it? This was positive. The first derivative was also positive. The second derivative was negative. The third derivative was negative. The 4th derivative is positive. And then because I'm going to be taking derivative of sine, I'm going to stay positive this time. So my 5th derivative will be, I know it's going to be positive, and it's going to add one more factor of 3. And this is going to turn into a cosine of 3x. See, I'm no longer doing the chain rule. I'm just looking at the pattern. What is the 6th derivative going to do? I've had 2 positives in a row.
3 to the 6th power, and then
-3 to the 6th power, and then what's the pattern on the sines and cosines? Start off sine, then cosine, sine, then cosine, sine, then cosine. So I should expect to see sine 3x, right? What about the seventh derivative? Positive or negative?
Negative.
Negative.
Negative. 3 to what power?
7.
7. Sine or cosine?
Cosine.
Cosine. You see, I'm not doing the derivative anymore. I've established the pattern. The pattern is that we go plus, plus, minus, minus, plus, plus, minus, minus, plus, plus, minus, minus. Each time another factor of 3 is added, and the sine and cosine just keeps alternating. The question was, what is the 50th derivative? All right, well, I'm not sure. Well, maybe, hold on. Let's talk about the sine or cosine. Do y'all notice there's a pattern for all the signs? All the signs we see. What derivatives are those?
Even.
Evens.
Oh, sorry, even.
Evens, right? When I do the 0th derivative, I get sine. When I do the 2nd derivative, I get sine. When I do the 4th derivative, I get sine. So it looks like if it's an even number, I should get sine, right? So I know 50 is even, so I know this should be a sine 3x, right? What about the 3 to a power? I know I'm going to have a 3 to a power. What power is it going to be? 50th, right? Okay. Which again, if you do 3 to the 50th on your calculus, I don't know, you might get an error. It's a huge number. So I'm just going to leave it as 3 to the 50th. The only thing left to determine, is whether or not it's positive or negative. And it's not a guess. We have to think about what's happening here. So I'm going to do it this way to try and help you see it. Here's the derivative, and here's the sign, plus or minus. So when we do the 0th derivative first, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. We started out, we went positive, positive, negative, negative, positive, positive, negative, negative, positive, positive, negative, negative, right? That's what's going on. So where is 50 on this list, right? If we get down to 50, what's it going to be? Now, I don't want you to literally count down to 50. It's too inefficient. What do you think I'm going to use here? Drum roll.
Division.
The what?
Division.
How? What do you mean?
Well, we'll grab the 15. We'll divide it by the change between the intervals.
Okay, yeah. So this is that mod thing that I told y'all about. Okay. We're having changes. We have like groups of 4 again. Right? We have positive, positive, negative, negative, positive, positive, negative, negative. Let's do this. Let's see. What happens? Let's look at, I'm going to look at these right here. I know if I'm over time, if you need to go, you can go. I'm just going to look at these right here, and I'm going to mod these with 4. So what is 4 mod 4? What is 5 mod 4? What is 6 mod 4? What is 7 mod 4? Okay, 4 mod 4 is 0, 5 mod 4 is 1, 6 mod 4 is 2, and 7 mod 4 is 3. You're going to have to refer back. Remember, you divide the number by 4 and tell me what the remainder is. So 4 divided by 4 is 1 with no remainder. 5 divided by 4 is 1 with 1 remainder. 6 divided by 4 is 1 with 2 remainder. 7 divided by 4 is 1 with 3 remainder. So this corresponds to plus. If we get a mod of 0 or 1, we get pluses. If we get a mod of 2, or if we get a mod of 3, we get negatives. So what is 50 mod 4? Let me do it down here. Goes in there 12 times, which leaves you a remainder of 2, doesn't it? So 50 mod 4 is 2, which means the sign will be what?
Negative.
Negative. There's one like that in your homework, but it's for sine. They want you to take the 50th derivative of sine of 2x.
We use 4 because we have the pattern of 4, right? Like,
Yeah, the reason we did mod 4 is because we have a pattern. The pattern takes four derivatives to start repeating itself, right? Plus, plus, minus, minus, and then it starts repeating. Plus, plus, minus, minus. If it were just plus minus plus, well, if it were plus minus, it would be easier because it would just be, you just look if it's odd or even. But if it did like plus, or yeah, plus, minus, then it would mod 6. Okay, do as much of that homework as you possibly can. Like I said, when we come back next time, we do another type of differentiation. We've learned all the rules, okay? But yeah, this week is this is a tough week. We got chain rule and implicit differentiation the same week, which those are two very intense topics. So please do your homework, because Thursday will be extremely tough if you don't understand chain rule. You need chain rule for implicit. Okay, everyone, have a great afternoon.
Thank
I'll
you.
hang out for a minute. I don't think I have to go anywhere right now. Yeah,
Okay.
I'm gonna be here, so I'll hang out if you have any questions.
Have a good day.
You as well.